All right, hi everyone. Welcome to Chapter 12's Solved Problems. We're going to go over two practice problems from the back of the chapter. One of them is on solving the economic order quantity, and the second one is going to be on solving the economic production quantity. So EOQ, economic order quantity, or sometimes just called Q with a little subscripted O, so you know it's for order. And then sometimes this is called EPQ, economic production quantity, but sometimes you'll see it abbreviated Q with a little subscripted P, like down here in the bottom left. So quantity, production, quantity to order. The idea is to figure out what the most economical amount to order is, and then based on that, you know how many times a year you're going to place orders, what your average inventory costs are going to be throughout the year, what your average holding cost or carrying cost of the inventory is going to be throughout the year, etc. And same thing with production, EPQ. It's all about figuring out how many units you should produce, and then by virtue of that, knowing how many times per year you should run production, or what the production costs are going to be, etc. Right? So there are a few other formulas you'll need. We're not going to do any problem with those. They have to do with reorder points, so make sure that you self-study on reorder points. There'll be at least one quiz question over the reorder point, but it's a really simple algebraic formula in chapter 12. So reorder point formula with certainty of demand is what you'll need to look out for. And again, that'll be a self-study thing because we're not going to cover it on the problem sets. All right, so let's start with problem number one, which is on EOQ. And this tells us that this person makes drones and uses 32,000 chips annually. The chips are used steadily throughout the year. They're open for 240 days a year for operation. They've assigned an inventory holding cost of $3 per chip, and placing an order cost $120. So we need to figure out the following information: how many to order, the number of work days in an order cycle, and I've also added a few more things to figure out as well, just because I think they're useful to go ahead and do them in this practice problem, add them onto this practice problem, because you're gonna have to do it in your problem set. So total cost, for example, figuring out the holding cost, ordering cost, all that. So let's figure it out. We need 32,000 chips. So capital D in this is the demand annually. If you have a formula that has a lowercase d on it, or you're given lowercase d, that would be the daily demand. So and that happens on this next one, I think, or maybe on your think for a second. I think it's on your actual problem that you're given maybe the daily demand, and you have to annualize it. But if you see a capital D, it's an annualized demand. S is your ordering cost. So think shipping cost. H is holding cost, also known as carrying cost. Those are used interchangeably. So holding or carrying has to do with holding on to inventory, storing inventory. So let's figure out first what is our cost of our quantity to order, right? So this is a formula right here, this very first formula. Make it a little bit bigger, that you'll want to familiarize yourself with. So it's the square root of 2 times D times S divided by H. So all of this stuff is calculated first, and then you find the square root of that. So if you're doing this on a calculator, you'd want to do 2 times D times S divided by H, and then just hit your square root button. So let's show you how to do that and solve it without Excel first. So D is the annual demand, S is your ordering cost, H is your cost of carrying inventory. And so let's just do it in the order that would be most appropriate on a calculator. Yes, you could hit the square root, your open parentheses and all that, but the way this works out, because it's all multiplication and the denominator is just a single character, it's best to just do them 2 times d times s divided by h and then hit your square root button afterwards. So 2 times d is 32,000 times s is 120, hit enter, divided by h is 3, and then we'll just hit our square root button, which usually looks like this on a calculator where my cursor is right now. We just hit that button and it finds it for us. The square root of that number is 1,600. So that would be your answer. That's the economic amount to order. We should order 1,600 every time we place an order. And then from there, we can figure out how many orders place every year, how many orders to, how many days we go between orders, etc. So what I'm going to do is I'm going to type in the answers, right? I'm going to solve it all with the calculator and then just type in the answers. So you can see where I'm plugging that in as if I was writing it down on notes. And then we'll go back and solve it in Excel the way you need to do it for your problem set. Okay, but for quiz reasons, for later on the exam number 2 reasons, you'll, or rather the exam reasons, you'll need to be able to do this by hand as well. So I'm just going to type in 1,600. That's our economic order quantity. And then the next thing I want to do after that is figure out how many days am I going to go between orders. So what I can do is from here, I can take the quantity and divide it by the annual demand. So this is how much I'm going to order. This is my annual demand. So the amount I'm going to order is 1,600 divided by D, 32,000. And I get 0.05. 0.05, what does that mean in days, right? So what this means is that 5% of the days we're open, I'm placing an order. It doesn't really mean anything to you, right? So we're just going to write this down, this 0.05, but that's not the answer. The answer has to be commuted into days. So we are open for 240 days. So basically 5% of all the days we're opening, we're placing an order. So we need to take 5% times 240 because we're open for 240 days of the year, not 365 or 365 and a quarter technically is how long a year is, right? Because of leap year. Anyway, 5% of the time we're placing an order, we're open 240 days. 5% of 240 is 12. That means every 12 days we're placing an order. So again, I'm doing this by hand for you to know how to do it for the quiz. Typing this in and submitting it will not be good for the Excel file, right? So, right. So, oh yeah, that's right here. So 1,600 divided by 32,000 is 1/20th of the year, but the year is 240 days. So it's every 12 days we're placing an order. So that would be what A and B is asking us in the book. But let's figure out what our average inventory is, orders per year, and total cost as well. And we need to know these things because your practice or your actual problem requires you to find them. So let's go ahead and solve it on the same practice. Average inventory is equal to the amount that you order divided by 2. The amount of any order divided by 2 would be the same as what you start that order period with, divided, and then what you end that order period with is approximately equal to the average amount of inventory you have on hand at any given time, is half of what you ordered. Because you'll start with 1,600, you'll end with 0 at the end of the period, and you'll have new ones arrive, right? So 1,600 and 0 averages out to 800. Same thing as 1,600 divided by 2. So this relates back to the chapter 11 is what I'm getting at. All right. So 1,600 divided by 2 is your average inventory. 800 is here. Orders per year. The number of orders per year is equal to the amount of demand you have divided by 1,600. So it's the reverse of this one. This is Q over D. This is D over Q. So I've got 32,000 demand divided by 1,600, my economic order quantity. So 20 orders every year. I'm placing 20 orders a year to get me through the year of chip demand. Now let's figure out our holding cost and our ordering cost. So you can see here total cost is equal to this formula times this formula. Well, carrying cost is Q over 2 times H. Ordering cost is D over Q times S. Well, we just found Q over 2 right here. So all I have to do for carrying cost is Q over 2 times H. So our Q over 2, which is our average inventory, is 800. Our H is our holding cost, $3. So on average, we're going to have $800 units on average. And our average inventory cost is $3 a unit. So times 3, 2,400 a year in carrying costs. Okay. And then we're going to have our ordering cost is D over Q times S. D over Q is the number of orders per year. So our ordering cost is equal to the amount of orders a year times the amount of orders we place. So just to place an order, we're looking at 20 orders a year times right here, $120 to place an order. It's 20 orders a year times 120, 2,400. Is there anything standing out about those two numbers to you? Your holding cost and your ordering cost. Anything pop out at you? Yes, that's right. They're the same number. So if you use exactly the order quantity and you didn't round this number in any way, your holding cost and your ordering cost on EOQ models will be the same. So your total cost will be the holding cost plus your ordering cost, or carrying cost plus ordering cost. Either name's good there with holding or carrying. Those two things added together for your total costs of ordering, and they're the same number twice. So 2,400 is 4,800. And that would be the solution to all of these problems if we were doing it by hand. Now, this is not true of EPQ models. The EPQ models uses a different formula. They will not come out. Your production run and your carrying cost will not come out exactly even with that. They're usually pretty close, but they will not come out exactly even on that model, just on the EOQ model. So it's a good way to check. Instead of just finding total cost by doing this plus this, find them individually. And by finding them individually, you'll know that your Q is correct because, well, you'll have a better feeling, more confidence that your Q is correct because these values came out to be the same amount. If they didn't, if they're wildly different, you're probably wrong on Q, or you did this formula wrong. If they're really close, they're within a couple bucks, well, that's just because maybe the Q got rounded to the nearest whole number. And so it's off by a few pennies, and then that gets multiplied. You're off by a few dollars by the end. Right? This was like 23.90 and this was 24.10 or something. That's fine, right? You're a few dollars high or low. You can it should be equal if Q is exact. If Q is rounded, it'll be pretty close to equal. All right, so let's solve that all in Excel with references, which is nice because we'll be able to see the increase in total cost if we order a few more chips for safety reasons, right? So Q is equal to, right here, 2 times D times S over H, and it's the square root of that value. So with Excel, we can type in square root SQRT, and then we want to find the 2 times D times S over H. To find the square root of that. The way that the order of operations works, we don't need to put parentheses around 2ds over H first, but so you can help visualize it to see that all the calculations are done in the numerator first. I'm going to go ahead and open a second set of parentheses. It's not technically needed. So it's going to be 2 times D times S. I'm going to close my parentheses in the numerator, divided by H, close my parentheses on the entire formula, and then hit enter. And you'll see that it comes out to 1,600 as well. So there's the formula for that. That's square root of 2ds over H. And again, I only added those parentheses that you'll see in red here just to show that that calculation is being done first. Technically, it doesn't need that because it'll multiply everything first, then divide it. But if there was addition in this top one, and you'll see that there's addition in the EPQ formula, probably a good practice to just add the extra set of parentheses here, but it'll still come out without them. All right, Q over D. Well, that's going to be equal to Q divided by D. And then we need to figure out what is that in days. Well, in days, that's equal to 5% of times days for open, well days. Average inventory is equal to Q divided by 2. Days per year is equal to D divided by Q. Holding cost, Q over 2 times H. We already know what Q over 2 is. It's average inventory right here. So instead of doing Q over 2 and then times H, I'm just going to click on average inventory times H. And then holding cost is D over Q times S, which is orders per year times S. D over Q times S, 2400. And then that's just going to be that plus that. So equal sum of that or that plus that, 4800. So that's the Excel method and the manual method with the calculator. Pen and paper, where I just kind of wrote them in there as well. Let's look at EPQ now. EPQ, unfortunately, is a little bit more complicated of a formula. It requires multiplying 2 square roots together. So the economic production quantity is equal to the square root of 2ds over h. So that same formula, right? So find that multiplied by your things to do with production. Number of units used per day, how much production is in a produced every day, and there's a value over there. So you have to find the square root of this and then multiply it by the square root of that. So when you're doing it by hand, I find it most useful to find this number, write it down. Hopefully it's a whole number, but if it's not, write down as many decimal places as you can stand. The more the better, the more accurate you'll be, the more decimal places you write down. Write that number down. Then find the square root of this, write that number down. Again, this one is usually going to be a very small number, like 1 point something, something, very small, usually a very small number. It might be less than 1. I mean, it could be a very small number, right? So write those 2 numbers down, then do this one times, and type in the other one, multiply them. So what I'm going to do when I'm doing it by hand is I'm just going to write down one, write down the other, and then write them all into the calculator afterwards. So 2ds over h, we have that value already. So that one's the easy one, right? 2 times d, which is annual demand, times s, which is the production startup cost. Instead of ordering cost, it's the amount to start up a run. Times or divided by h, which again is still holding cost. That didn't change. The only thing that changes with EPQ, production quantity, is that instead of ordering it, you start up a run. So the S could be called shipping cost, and maybe that's not technically. And then the S could also be startup production cost. These are the same letter for both. All right, so 2 times D, which is 11,000, times S, which is 70, divided by H, which is 2, and then hit the square root button, and we get long number. So I'm just going to write that down, 877 point. I'm just going to go up to several decimal places. Can I copy this from the calculator? No. Oh, I can. Good. So I'm just going to go out to several decimal places there. I don't need to go all the way to like 20 decimal places because it's a repeating value, but I would go far. I would go a minimum of 5 decimal places here, just to be as accurate as possible. The more you go out on this, the more your Q is going to be accurate. I would say a minimum of 5 decimal places if it's still repeating. That'll ensure that your production quantity is correct if you had to do this on a quiz or by hand. All right, now we want to find the square root of P divided by P minus U. Sure. P is how much production we can do in a day. So we can do 200 in a day. Minus, I'm going to open my parentheses, P minus U. So P is 200 minus, oh, I did divided by, sorry. 200 divided by, open my parentheses, 200 minus 50, close my parentheses, hit enter. So I'm doing 200 here on P divided by P minus U. 200 minus 50 is 150. So it comes out to 200 divided by 150. You can see that's 1.333 repeating. I'm just gonna write that down, 1.33333. Again, I'm gonna write it out 5 decimal places. Now I found the square root of this. I found the square root of this. I'm gonna multiply those together. So I'm just gonna type them back in, 877.49644 times 1.33333, enter. And I get 1169.9923. One second. Oh, of course. I skipped a step. Knew that didn't seem right. I only did 200 divided by 150 here. I didn't find the square root of it. I knew it didn't feel right. Kept second guessing and looking at it. And of course, I need to find the square root of this times the square root of this. I didn't find the square root of this. I only found 200 divided by 200 minus 150 minus 50. So 200 divided by 150 is 1.33 repeating. Now I need to press my square root button. 1.1570. 15470. And I'm just going to go out to like that many spaces and paste it here. All right. So now we have the number. I didn't feel like it was small enough. I thought it was closer to 1. All right. So we got 877.49644, which is the square root of this here, times the square root of this here, which is now here, 1.1547. 1.1547 point. There we go. And we get 101324. So let's round it to the nearest whole number, 1013. All right, perfect. So that's going to be our economic production quantity. We should produce 1013 units every time we produce. Great. Now, is that feasible as a number? It's a weird odd number. So with EPQ and EOQ, it might be better to round to a bigger number. It might be more realistic or feasible for placing orders. 1600 is a nice round order. 1013, you're probably better off, just calling it 1,000 and then having one more production run perhaps, but we'll call it 1013 for this purpose. All right, now how many runs do we do in a year? The number of runs per year is D divided by Q. You are open for 200, annual demand is 11,000. 11,000 divided by 1013 is 10.85. For 10.85 runs, you either have a run or you don't, so that needs to be 11. We'll just round it to 11 if you're doing it by hand. All right. 10.85. Yeah. All right. So IMAX. IMAX is not the large movie theater in this case. Instead, it is your maximum inventory that you're going to have on hand. So we're going to find that, and the IMAX is equal to Q over P times P minus U. So Q of production is this 1013 that we found. That number divided by production demand per day, so 200. Not demand. Production units per day. How many we produce a day? And then we're going to have that number times P minus U. P minus U was 150. That was this right here. So let's do this one real quick. We've got 1013, which is Q over P, or QP, which is EPQ, same thing, production, economic production quantity, divided by production units in a day is 200. 200. We're going to multiply that by P minus U. We already know, we can do quick math on that. and say 200 minus 50 is 150. So multiply by 150, and we get 759.75. So we'll say 760. If I have an EPQ question on a quiz, I'll have you do this to whole numbers. So no worries there. We don't need to write 759.75. Average inventory is going to be this number divided by 2. So instead of, what was it? The average inventory is Q divided by 2. It's actually IMAX divided by 2. We're going to produce all these, but there's a maximum we can have that we'll ever have in our inventory because we are producing so many units a day, but then using them up in production of our whatever it is we make. So yeah, I already wrote the formula there. IMAX divided by 2, so that's going to equal 760 divided by 2, 380. Consumption rate is IMAX divided by U. That's how much was being used daily. So 760 divided by 50, 15.2. And then the run length, we're going to produce 1,013 units every run. And then we are going to produce 200 every day. So to figure out how many days that lasts, we just need to take our Q of 1,013 and divide it by 200. So how many days does it take us to get to 200 to 1,013? That's the idea there. 5.065. 5.07 rounded up for us. So run length will last 5 days and some change. Now, here's where you probably want to play around with the numbers. 5 days of work, but it's a little bit over 5 days of work to produce this many. So it might be in your interest to produce a few more units or a few fewer units to get this to match up to your workday. That's where not just going with the raw numbers in making operational decisions is important. Doing the quantitative work, but then applying logic to it as well. Would it make sense to pay overtime every week because of the amount of the run, or should we change some of this a little bit so that we don't have to do, quite as so we don't go over it all, right? So if our run length was 1,000 instead, or if we produced 1,000 as our production quantity, it changes all the rest of the values. But let's say we only made 1,000 divided by 200, we could get it done in 5 days and not have overtime every week, and that might be more cost effective on a whole. All right, let's solve this one in Excel. So if you're doing this one, you can do this in 2 boxes. If you want to add a third box and then find this in one of them with a square root, and then find this in the other one with a square root, and then your third box be equals this times this, that's fine. I'll go ahead and do that both ways to show you it might be a little easier. But you can do this whole formula in one box. It's just, just a long formula, but that's fine. We want to find the square root of this and then multiply by the square root of this. So square root of, open our parentheses, 2 times d times s, close our parentheses, divided by h, close our parentheses again. So the square root of this, it's going to find all that. And that's the same formula we did for EOQ, right? But then we multiply that by the square root of P divided by, and now open our parentheses is important on this one because P minus U needs to go first. So we have to add it in parentheses. Otherwise, order of operations wise, it's going to do P divided by 2 minus U. But we don't want to do that. We want to do P divided by this bottom number. So open our parentheses again, P minus U, close our parentheses once for the denominator, a second time for the entire square root formula. So it's going to find the square root of 1 multiplied by the square root of the other, 1,013. So like I was saying, you could do, equals square root, if you were feeling anxious about it, equals square root of 2 times d times s divided by h here, and then do equals square root of p divided by p minus u, close parentheses twice, and then have that third value be equals this times this. Good. I don't have that set to round. I've got this cell set to round down for me, but you could do that. That would be perfectly fine. You can add those cells, but you can do the whole formula in one. It's not that much different. But if you want to do it in one, do it in the other, multiply just to double check your work. Feel confident about it before you submit. Go right ahead. Runs per year, D over Q, so equals D over Q. We get 11 still. Imax equals Q over P. So we're going to go. Actually, we do probably need parentheses. I think it'll do it without it, but that's fine. Q over P, close up parentheses, times, open parentheses, P minus U. To find the Imax, and we use Imax, actually this value really should be in this color, and then that's going to be equal to this divided by 2, and this is going to be equal to Imax divided by U, and then the run length is equal to quantity per year divided by amount produced every day to figure out how many days it takes to finish the run, 5.07. So the only thing complicated is just making a long formula, but it's okay. You can do it. All right, that's it. That's it for the quantitative work practice problems. Again, you need to self-learn on the reorder point. It's a simple algebraic formula. You don't have to do it on your problem set, but there is a quiz question over it. All right. Thanks, everyone. See you next chapter.